Question 2. A 1.5 meter conducting rod rests on a metal PQ and RS. So the rod is placed in a uniform magnetic field. So this is the magnetic field with a magnitude of 3 Tesla, perpendicular to the plane of the paper. Okay, so it is perpendicular to the plane of the paper, and the rod is pulled to the right at a uniform velocity of 3 meters per second. So if the resistance of PQRS is 5 ohm, determine the magnitude of the induced EMF, magnitude and direction of induced current, magnitude and direction of the magnetic force that required to keep the rod moving to the right at a uniform velocity of 3 meters per second. Okay, so the direction is, how do we find the direction? Is we are going to use the Fleming's right hand rule lah, this one. Okay, so remember, you have to be able to remember which rule should we use to determine the direction lah. Okay, so for this case, this is for the straight conductor, so we are going to use Fleming's right hand rule. Okay, right, so now question A, we have to calculate the magnitude of the induced EMF. So that is just EMF BLV sine theta. Okay, so theta is the angle between, sorry, let me double check. Theta is the angle between V and B. Okay, so B and V, I don't like to write it this way because I always get confused. What is the angle? Okay, so the angle is LVB, which is the angle between the velocity and the magnetic strength. Okay, magnetic flux density. Okay, so from there, then I can know which one is the angle that we need to look for lah. Okay, so sekarang ni kita tahu dia punya angle between the velocity and the magnetic flux is 90 degree because they are perpendicular to each other lah. Alright, so this is gonna be equal to 1.5, velocity is 3, v is 3 as well. So this is sine 90 degree, which gives you the induced EMF to be equal to 13.5 volt. Okay, alright, so we've done that. Now we have to look for the induced current. Okay, so for the induced current, since they gave us the resistance value, so we can just directly use the Ohm's law equation, which is this one. Hence we can then calculate the induced current V over R, which is gonna gives us 2.7 ampere as the value of induced current lah. Okay, and then how do you determine the direction? Is you will be using the Fleming's right hand rule lah. Okay, so our thumb is gonna be pointing our velocity, and then our magnetic flux will be determined using our pointing finger, and then our middle finger is for the induced EMF ataupun current. Okay, so use Fleming's right hand rule and you should get upwards as the solution lah, as the answer. Okay, right, now question C, we have to calculate the magnetic force pula. Okay, so remember magnetic force is calculated using the equation of, let me double check, where is it in the notes? Why can't I find it? Sorry, let me just check this real quick. Skip this part. Okay, F is where is it? Okay, so basically F is gonna be equal to ILB sine theta lah. Okay, why can't I find the formula? Kamu ingat ka di mana tu? Force. Okay, never mind. But we are gonna use that this equation. So this one's gonna be between the angle between the link and magnetic flux density, if I'm not mistaken. Is it between the current of the magnetic flux? Okay, let me double check. I just don't want to give you false information. Where is it? Okay, its direction is there's only one force. Yes, there's only one. Okay, that's weird. I can't really find it in the notes. I'm not sure if I've included this in the notes. I should, right? But it's okay. I'll double check where did I put it in the notes. But the formula that you will be using is F equal to ILB lah. Okay. Alright, yes, can't find it. Okay, so you will be using F equal to ILB sine theta, so you should get 12.15 Newton, and the direction is to the left. Okay. Alright, so that is the solution for question number 2.